Good morning, students. In this lecture and in the next lecture, we will study basic electric circuit components and circuit analysis. We will discuss about SI units, electric circuits, direct current and alternating current, resistor, capacitor, inductors, Ohm's law and Kirchhoff's laws, power dissipated in resistors, resistors in series and parallel, voltage division, sinusoidal quantities, and circuit symbols. To start with, the basic SI units, some of the basic SI units are given in this table. For example, the unit for capacitance is farad, the unit for charge is coulomb, the unit for current is ampere, and the unit for electromotive force is volt, for frequency hertz, period, second, resistance, ohm, and so on. And we have prefix which comes before the units, and they are used to represent very small numbers and very large numbers. For example, if we talk about tera, it is 10 to the power of 12. 1 terabyte, for example, is 10 to the power of 12 byte. Mega, 1 megahertz, 10 to the power of 6 hertz. Kilo is 10 to the power of 3. Micro, 10 to the power of minus 6. Pico, 10 to the power of minus 12, and so on. Now let's come to charge and current. An electric charge carries electrical energy. It can be positive charge or negative charge. The flow of current at a certain point per unit time is called an electric current. It is the flow of charge per unit time. So the unit of current will be coulomb over second, okay, which is ampere. We'll come to that. A current flows in a closed circuit. For a current to flow in a circuit, the circuit should be closed. Electromotive force and potential difference. The stimulus or the excitation that causes a current to flow in a circuit is called electromotive force. An electromotive force represents the energy introduced in a circuit. For example, it is represented by a battery or generator. An electromotive force results electric potential at each point in a circuit. And we can have potential difference or voltage between 2 points. This is a very simple circuit. We have an electromotive force, which is a battery, and the current is flowing, and this is a load. This load can be, for example, a resistor, it can be a motor, or some other electrical device. Across the load, we have potential difference, and we have this arrow, and the head of the arrow shows higher potential, and the tail lower potential. So there is potential difference across the load. We can make analogy to the flow of current in a circuit to the flow of water in a pipe. For example, the pump represents the voltage source. Okay, it's similar to the voltage source. And the pipe is similar to the wire where the electric current flows. And the water is similar to the current. And if we have, for example, a narrow section of the pipe here, it represents a resistance where there is potential difference, or in this case, in the case of the water, there is pressure difference across this narrow pipe. Now, we represent circuit elements by symbols. To simplify the analysis and the study of electric circuit, we use symbols. For example, here I have a battery here, a switch here, and a lamp here. So the lamp is represented by this symbol, the battery represented by this, and the switch by this. This is the switch is open. So these are some of the symbols which are used for electric circuits. Series and parallel circuit. We have here a series circuit, a battery connected to 3 lamps. In a series circuit, the same current flows in the closed path. If the circuit is broken at one point, then there will not be current through the circuit. That means all the lamps will be off. In a parallel circuit, they have different branches. For example, here, each lamp have its own branch. So total current is divided across the branches. So if one of the lamps goes out, then the other two, they stay working. Measuring current. How do we measure current? An instrument used to measure current is called ammeter. In the lab, we have it as a voltmeter, as a multimeter. So this multimeter has, for example, it can be used to measure resistance, it can be used to measure current, and when it's functioning as an ammeter, or it can be used to measure voltage. So I have here in this circuit, this A represents the ammeter. There is an ammeter which measures the current passing through this circuit. And this is a parallel circuit, and this ammeter will measure the total current which is going through the 2 branches. And for measuring voltage, we use voltmeter, and the symbol in a circuit diagram is represented by this. So when we measure voltage, we connect in parallel to the element. For example, if I want to measure the voltage across this lamp, I connect the voltmeter in parallel to the lamp. Remember, to measure the current, I have to connect it in series to the element. Here also in parallel. Ohm's law. Now, Ohm's law says if a current is passing through a certain resistance or a certain element which have a resistance, then the voltage is equal to the current times the resistance. Or alternatively, if we want to measure the resistance, then we measure the voltage across the element and the current passing through that element. And in that way, the resistance will be voltage divided by current. And this is a series circuit, for example. This is a series circuit, and 2 ampere is passing through in this circuit in both the 2 lamps, lamp 1 and lamp 2. And we have this parallel circuit. In this parallel circuit, I have a total current 2 ampere divided between the 2 lamps, and 1 ampere in one lamp and 1 ampere in the other lamp. Explain what happens to the current in a series circuit when there is a break in the circuit. Of course, when there is a break in the circuit is no longer complete. Remember that for a current to flow in a circuit, the circuit should be closed. So, therefore, the current cannot flow. Explain what happens to the voltage across each bulb as more bulbs are added to the circuit. When we add more bulbs to a series circuit, then the voltage across each bulb decreases because the total resistance increases and the total current passing decreases. And remember, voltage equals to current times resistance. Since the current decreases, then the voltage across each bulb decreases. Explain what happens to the current in each bulb as more bulbs are added to the parallel circuit. The current in each bulb remains the same because they share the same voltage and the voltage stays the same. It is in parallel to all the branches. So the current in each branch remains the same. the total resistance drops and the total current increases because the total resistance drops. Some practical examples of series and parallel circuit. For example, if we have a Christmas tree light, the Christmas tree lights, each light is connected in series to each other. So we have a series circuit. Parallel circuit, if we have, for example, our lights, the lights in our houses, they are connected in parallel. If one of the lamps goes off, then the other lamps will work. Voltage representation. So when we represent voltage, we represent it with respect to a reference. And most of the time, our reference is the ground. So the ground is zero potential. And we measure the voltage with respect to the ground. For example, if you see here, the voltage at this point, because this is an arrow, remember, the head of the arrow shows the higher potential and the tail shows the lower potential, and the voltage at this point with respect to the ground is VA. And we have the voltage here across this element VB. Currents in electric circuits may be constant or they may vary with time. When a current varies with time, it can be unidirectional or alternating. Okay? Unidirectional means it is flowing in one direction. It can be only clockwise or only counterclockwise, for example. Or it can change directions, alternating current. In that case, sometimes clockwise, sometimes counterclockwise, alternating current. And another type is direct current. Direct current always flows in the same direction. Direct current always flows in the same direction. Some of the basic circuit elements are resistors, capacitors, and inductors. These are the basic circuit elements. A resistor provides resistance to the flow of current. They oppose the flow of electricity. And the unit of resistance is ohm. And the symbol for it is given by this. And capacitors. Capacitors, they store energy in an electric field. A capacitor stores energy in an electric field, and it's measured in farads. The symbol for the unit is F. An inductor stores energy in a magnetic field, and it's measured in Henry, and the symbol for the unit is H. I hope you understand this lecture. In the next lecture, we study the basic circuit laws and circuit analysis, and we will have some examples how Ohm's law and Kirchhoff's current law, we apply Ohm's law and Kirchhoff's current law in circuit analysis. I hope you understand this lecture. If you have any questions, you can always email me. Thank you.